Hi, and welcome back. In this video, I'm going to show you a machine learning indicator using a classifier for trend predictions. This table shows the prediction results on validation data, meaning on new unseen data. And the total accuracy is around 52% for this particular example. This is going to be dependent on the model we're going to use. Also, we have access to the separate accuracies for the 3 trend categories that we considered in our simulation in this experiment. So first we have the ranging price, category 0, downtrend, category 1, and the uptrend that we labeled category 2. If you are into machine learning classifiers and you've already used and you are already familiar with this field and related metrics, the ROC curves show positive signs of predictability, meaning the forecasting, although not perfect at this stage, is still capturing a signal about the future of the trend. And this is how the signal looks like on the chart. So here we have false bearish signal because the price went up afterwards. Here we have a bullish signal. We didn't really have an uptrend afterwards, although we have 1 day of a green candle. This is the daily time frame, by the way, so each candle represents 1 day. These 2 signals are bearish signals, and they are good because for the coming 4 or 5 days, we have a downtrend. So this is a really wide range. It could have been a really good trade right here. And this is an excellent bullish signal as well detected by the model because the price went straight up afterwards. So if you notice, we're trying to use the model to pick entry points at candles where we can enter with maximum chances of profit. So now I will show you how I trained the machine learning model so you can reproduce the same results. And if you are here for the coding part, the Python code I'll be using is available for download from the link in the description of this video, so you can download it for free and run this experiment from your side. Our quick plan is the following. First step is to get the data, add some technical indicators. I have added more than 20 indicators as input features, ranging from momentum indicators, oscillators, trend detection, volatility, and volume-based indicators. We will go through the details later on in this video. Then we need to label the data. I will also show you how I did this step by step in details, looking into the average closing price of future candles and comparing it with the current candle. Then we train the machine learning model on the training data set. We will evaluate its prediction metrics on the test data and the validation data or using unseen data set. And finally, I will show you how the indicator looks like on the trading chart so we can analyze its potential for trading strategies. Now, for the labeling, we will choose a fixed time horizon, meaning we will look into how the price changes in a fixed number of candles in the future. Imagine this is the current candle and it closes at this price level. We will define a threshold area in number of pips or a percentage of the price. We will look into the future considering a fixed number of bars. Next, we compute the average closing price of these candles, and we check if the difference with the original closing price of the current candle exceeds the threshold boundaries. In this example, the average is still within the threshold area, so we have a ranging market, and the label of this current candle is 0. If the average of future prices crossed above the threshold area, we have an uptrend, and the label is 2. In the opposite direction, if the average closing price of the future candles is below the threshold and the label is set to 1. So at the end, we will get a data set with all the input features, but also the labels. We can compute the multiple labels in this case, changing the number of future bars and the threshold width, so we can optimize our labeling method as well. We will be using a grid search approach to compute those different labels using different thresholds and different future candles. Now, just as a side note, this is not a look-ahead bias. This is a labeling technique, a labeling approach. It allows the model to peek into the future just during the learning or training phase. But these values are not provided to the model during the prediction or the testing phase or the validation phase. Now we can move on to the Python code, train the model, apply predictions, and have a look at the results. So this is our Jupyter Notebook file. First of all, I'm importing whatever is needed. So I'm using yfinance for the data to import the data, then scikit-learn and xGradientBoost, matplotlib for plotting, and so on. I'm downloading the data. For now, you can change the label to download different stocks, the date, the starting date, and so on. So this is just to download the data. We will get a data frame that looks like this. We have the close, high, low, open, and the volume, and the date for each of those rows. Then we have the feature engineering part or technical indicators added using pandas _TA technical analysis. So this is just a helper function that we're going to use later on now to merge the indicators into our original data frame. And then one function named add_indicators is going to compute the indicators, the momentum indicators and the RSI with different length. For example, we are using RSI length 5, 10, and 15. This is why it's in a for loop. So it's going to add 3 different columns. We have the ROC 10, momentum 10. We're going to merge these together. We have the CCI 20, WR 14, and so on, the MACD as well. We're also adding simple and exponential moving averages with length 5, 10, and 20, as you can see here. And the volume W moving average, volume weighted moving average 20, and so on. So I'm not going to list all of these. You can add all kind of indicators here. You can add your custom indicators. This is where you can experiment by adding as many indicators that you want and probably applying some dimensionality reduction later on if needed. And now our data frame will look like this. On top of the original columns, we'll get the additional columns of the technical indicators we just added. Now for the label, we're going to compute the average closing price of future candles using a certain look ahead, a negative look ahead, for example, for the future 5 candles by default. And then there's a threshold of 0.01. So that's a percentage of the current price. If the price went above by a certain percentage above the threshold, then we have a return to. It's a bullish trend, let's say, bullish future trend. Otherwise, if the average of the future closing prices of the future candles is below the threshold, it's a downtrend, so we return 1 in this case. Otherwise, we return 0. We don't have a clear trend. It's a ranging market. So we can, I've put this into a function, so called generate label. So we can change the look ahead into, let's say, from 5 candles to 10 candles in the future, 15 candles in the future, and so on. And also we can change the threshold. And also we can change which part of the candle we're looking at using the closing price by default for this example. So here you can see that we're using a grid search approach. The look aheads we're going to test are 2 candles in the future, 4, 6, 8, and 10 candles. And we're checking only 2 thresholds, either 1 or 2%. You might want to add more values here to make the test more complete, but it's going to cost you more compute time. And now in the data frame, we can see that we have the original columns, open, high, low, and close, and the volume. We have the indicators, but we also have different labels that you can see here. So that's label, let's say 2 candles in the future with a threshold of 1% change, 2 candles, 2% change, 4 candles in the future, 1%, 2%, and so on. So we can see that we have all the labels of the grid that we have defined in these 2 lines right here. Then we're going to split the data into training, testing, and validation, or validation and testing. You might want to name it differently depending on which book you've been reading recently. But anyway, we're splitting these into 3 slices. You might want to use 60-20-20 or 80-10-10%. It's not that important really. When it's working, it's working. When it's not working, we'll know that it's not working. Then we're defining the baseline X gradient boost performance. So we're defining the model first of all with the hyperparameters. We're not going to fine tune the hyperparameters at this point. We're just trying to check which of the labels in this data frame will provide the best result. And the way we're going to do this is that we're going to train and test the model on all of the labels. So we're going to use all of the labels and we're going to concatenate the results in this list. Remember, this is a for loop. It's going to loop over all the labels. It's going to split the data, train the model, test the data. This is the training here with the fitting function. Then it's going to predict on the testing part or the validation part again. Then it's going to compute the accuracy, the F1 score, and we're going to append the results in the results list. Then we sort the list of these labels for one same model, actually, depending on either accuracy or the F1 score. So this way we can see how the label is affecting the same model using the same data. So we can have an accuracy of 0.86, which means actually nothing, because if the model is very not sensitive, let's say, and it's predicting category 0 by default, like this category, we're going to easily get something above 60% of accuracy, because most of the candles are not labeled either 1 or 2. So I have the tendency to look both at the F1 score and the accuracy together as a first glance. But anyway, the good news is that we can try all of these. So now that we can choose which label we are going to use, so probably you will want to use either the highest accuracy or the highest F1 score. In this case, you can say, let's say the best label is the maximum among the results using the F1 score, for example. I've used the F1 score maximum. So that's going to be this model right here. 10 candles in the future, a change above 2%. You can also, if you want, you can also override this. So you can uncomment this line and choose whatever label you want to experiment on. So now that we have chosen the label that we're going to use, we can tune the hyperparameters of our machine learning model. So this is where it's happening. We're also using a grid search approach. So these are the hyperparameters, and we're providing a range or few values for each of these parameters. And then we're going to test the model with the different parameters using our best choice of the label. We're using the grid search function, providing this dictionary where we have different values for different hyperparameters. So that's around 810 fits for this example. It's going to repeat this job 810 times in order to provide the best set of hyperparameters. Now we have a total accuracy of 76% for now. And then we can see the classification report. We can see that for the category 0, which is not of interest, to be honest, for us. This is a ranging market, so that's not our purpose. 73% precision, unless if you want to apply this for a ranging market strategy, that might be interesting. Then we have category 1, which is the downtrend prediction with a precision of 16%, and the bullish prediction is 62%. So that's a bit more accurate in this case, a bit more precise. We have the recall, and we have the F1 score for these two. Now, if we test the model, the machine learning model on new and unseen data, let's say the validation set that we haven't used so far, we're losing the precision that we got on the bullish part. The bearish part is somehow kept the same. We kept the F1 score, we kept the recall, and we kept somehow the precision. And also the category 0 is kept as is. So this is, again, we're not using the best label. I've chose the label with the best or the highest F1 score. We could try with the highest accuracy or just choose something which has a compromise in between. If we check the classification reports of these different labels, we might want to choose a label manually, which will probably provide better results. Now, there is a way to make the model a bit more selective and improve the results, improve the precision. Instead of making the model predict a category straight away, we're going to extract the probability for each of these categories, the predicted probability by the model. And in this case, we're going to set our threshold manually. So if the probability of a certain category is above, let's say, a threshold of 55% or 0.55, in this case, we're going to confirm that this is a bearish sell, for example, or a bullish in the other case. So we have two thresholds, one for the category 1, a bearish, and one for the bullish category. Then we can use this function in order to extract the probabilities. And then we're going to compute the predicted categories based on the new thresholds that we have set. So in this case, we can see that we have few predictions in the bullish category. We have few predictions in the bearish category as well. And we have category 0 as well. So it's populated with a precision of 68%. So this is how we can play with the model parameters, the prediction probability, the hyperparameters, and the labels that we've started with in the beginning. We can also improve the indicators that we started with in the data frame at the beginning of this video. Another interesting thing that we can use SHAP, it's a library where we can compute the effect, actually, the weight of each of the indicators that we have used on the results. And for each of the classes, you can see that we have 3 colors. So each color is for one class, class 1, 2, and 0. And this graph is going to show for each of the indicators, each class, how much is it affected by the indicator itself in terms of predictability or forecasting. So we can see that the simple moving average 20 is affecting mostly the pink category, which is the bullish class 2 signals. It's also affecting this green thing, which is class 0 and class 1. I could say in a very equilibrated way. You don't have a lot of bias in here. Instead, this one, for example, the NVI, you can see that it's mainly the blue category, which is the bearish signal, and so on. We obviously tend to keep in the data frame the indicators that are going to have the highest effect as a stacked effect on the 3 different categories. So this is just to provide an idea that some of the indicators are contributing a lot to the predictions and some others are contributing much less. And now we can plot the indicator itself. So I'm going to show you here in red triangles, we have the labels. So this is how our labeling worked. And then we have the purple points are the generator or the forecasted signals. And as you can see, in some cases, we have opposite signals. This is really bad because we have a bearish prediction here while the label is bullish. Here we have bullish signals, bullish labels, and the model is predicting bearish. But sometimes, actually, in this case, for example, it's predicting a good bearish signal, and it's capturing actually the exact moment where we could have entered with a good return. It's at the closing price of this one. It's a good bearish signal. Here as well, we have a good prediction, as you can see. This one as well is a good signal, a bearish signal. This as well, here they are good bearish signals. So in total, we have some good predictions and some bad predictions, and this obviously can be improved, but you have now the this Jupyter notebook is a good frame to start with. You have the visualization part, you have the starting part, you have the different labeling parts, and so on. And just to make sure that we're not totally working in the blind, the ROC curves actually here, they show a positive pulse. So the model is not totally dead. It's not a random model. It's not randomly choosing between 0, 1, or 2. It's actually showing a positive predictability potential when it's showing these curves above this middle line, which somehow represents a totally random model. So this is a good news. It can definitely be improved. And this will be it for this one. I hope you guys liked it and found the information helpful. I know it's not a full trading strategy that's going to print money overnight. Please don't trust me in the comment section. This content is mainly dedicated for people who are learning to code their own strategies, to put them into Python, backtest these, and include complex indicators using AI, machine learning, and so on. Until our next one, trade safe and see you next time.